Okay, so I think we'll go ahead and get started here. Good morning, everyone. I want to welcome you to this presentation of Novedge's Best of the Best webinar series. My name is Vince, and I'll be emceeing for today. I want to thank all of you for joining us today, and I want to thank Lattice3D and Bill Barnes for participating in this. Just a little background on Bill. He's been involved in CAD/CAM manufacturing for over 30 years. Beginning as a user while a tool designer for an aerospace and defense contractor in England, and has since moved to the software vendor community in '83. He's worked in sales, channel management, product management, and business development. Before joining Lattice Technology, Barnes was director of international sales at Actify Inc. and was responsible for channel development and management. Prior to Actify, he served as vice president of sales and marketing for Stereographics. So needless to say, he is truly an expert. We're really fortunate to have him on board with us. Bill's going to speak for the next 40 minutes or so. During that time, everyone will be in listen-only mode, but please feel free to send your questions into the question box. At the end, we'll open it up for a Q&A, and we'll get to as many questions as time allows. We will be recording this webinar, so if you have any issues with it, we will make the recording available to you afterwards, and complete details will be given as soon as Bill finishes his presentation. So having said all that, I think we're going to go ahead and turn it over to Bill. Bill, can you hear me?
Yes, can, and I hope you can hear me very well as well.
Yeah, your audio is coming in great. So we'll go ahead and switch the screen over to you guys and get this thing started.
Great, thanks. And Vince, thanks for that great introduction. Make me blush a little bit there. So cool. All right. Well, hello, everybody. As Vince said, my name's Bill Barnes. I'm with Lattice 3D, also known as Lattice Technology. We're based out of San Francisco in California, headquartered in Tokyo, Japan, where our company's been around for around 14 years now, and our products are used worldwide from very small companies up to large multinational companies like Toyota and Boeing. So with me today is my colleague Masaru Hatakoshi. He's going to be driving the software, and as we go through today, we're going to use our XVL Technical Collaboration Suite, which includes our XVL Studio product with our technical illustration tools and our animation tools, as well as our what we call our multi-CAD import option, which lets us read CAD files directly into our product. So with that said, I know we've only got about 40 minutes here. Let's get started. We're actually going to start by looking at a SolidWorks file. And Masaru, maybe you can show the size here. It's a pretty small file. It's just 10.5 megabytes of SolidWorks data, but we're going to import that directly into our XVL Studio application by dragging the top-level ASM file into the product. And we chose this file because it includes not only an assembly, but it's also got a sub-assembly, a number of parts, and also a number of instances of parts. So we want to show how we handle that with our XVL Studio product when we're importing the data in. So you can see we're running this. Just so everybody knows, we're running our product here on a Dell laptop. It's an E6400, a pretty bog standard workhorse today. So we've imported the data into XVL Studio. You can see on the left of the screen we have the full assembly tree that came in from the CAD data. And sorry, maybe you can right-click on one of those entities and we can look at the Properties tab. So you can see, as well as reading in the geometric data, we also read in any non-geometric data that may be stored with the part as well, so we can use that when we're publishing information later. Okay, great. So I was going to tell you which formats we supported while that was importing, but it was pretty quick. So we support, with our multi-CAD import option, most major 3D CAD formats from companies like Dassault Systems with CATIA and SolidWorks, the Siemens range of products, NX, Solid Edge, and Autodesk products like Autodesk Inventor, the PTC Creo line of products, and a number of others as well. And they're all included in the ability to import those is all included in the collaboration suite. So let's go ahead and get started. The first thing we're going to do is create a technical illustration from this data and show you how we do that and how we publish that out. So first thing we're going to do is set the viewpoint. And most illustrators will like to choose a standard isometric view, and you can see we have presets installed in the software that let us easily step through, choose the one we want. And when we've decided our viewpoint, we can actually go ahead and what we call register the viewpoint, which lets us save the viewpoint so that as we navigate around the part, we can easily step back to the view we're going to use for publishing data. Okay. So first thing we want to do is introduce a concept we call snapshots. A snapshot is not a 2D image for us. It saves the 3D state of the model. So that means that any step in the process, we can use this to capture a 3D state, including the camera position and the state of parts, whether they're cross-sectioned or maybe that we've changed the color or something. But in this case, we're just going to call this the original view. So Masaru did this so he can easily go back and reset the view at any time he wants to. Okay, to create the illustration, we're going to introduce another concept of XVL, which is the ability to handle multiple bills of materials within the product. In this case, we're going to create what we call a disassembly tree, which can be used as an SBOM for creating service, for example, for creating service documentation. And in this case, you can include all of the parts in the model or some of the parts in the model, and you can add additional attributes, as you'll see when we do this, such as part numbers that you may want to include in call-outs when we add them as we go through. So we've built the disassembly tree automatically by just including all the parts, and you can see it's indented to include sub-assemblies where necessary. And then we're going to go ahead and lay out the parts for the illustration. And to do that, we're just going to use the move command that's in XVL Studio. So we simply select the part and drag it out and put it to the position we want. And I hope you can see that we automatically created the center line or trace line, and we can do that for all of the parts in the model. So I'm going to let Masaru go ahead and lay out all the parts exactly as he wants them to appear in the illustration. So what we're doing now is, as well as single parts, we're able to select multiple parts to include in a single operation. So as you would do this here with this group of bolts, and we can create the trace line for all of them. And I'm sorry, I was just going to redo that because I think he forgot to turn on the trace line option for multiple parts. Okay. Now, when we move them, the trace lines will appear. There you go. Thanks, Masaru. So those are multiple parts are examples of what would have been instances probably in the original CAD model. But that means, typically in the CAD model there would be a single part and it would say 5 places or 4 places or something. And when we convert to XVL, we actually build new geometry for all of the different instances. So you can work with them individually or as a group. And what we're going to do now is another technique, which is to move multiple parts but create a single trace line for the parts rather than a trace line for each part. And also show here how you can have a jobbed trace line or a multi-step center line, as you often see in an illustration with the appropriate levels of geometry. So there you can see Masaru's very quickly laid out the parts all in an isometric view here and ready to publish. Now there's one thing I noticed there, that the trace line that goes back across the part probably should be moved. So trace lines or center lines are first-class entities within an XVL model. So we're actually able to edit and move them individually as well, so which enables you to get the illustration looking exactly as you want it. So in this case, we can just jog that position. Okay, so now we've got ourselves to a position where we're ready to go to the next step, which is to maybe add some numbers or callouts to the part. So the first thing we need to do is decide how we want to number the nodes of the disassembly tree. And in this case, we see everything there. We can just simply say renumber the nodes, and it will apply a number to each of the parts that we have. So you can see there on the tree we've 1 through 13, I think. And you'll also notice that where you have parts with the same name, such as the cap bolts, they've all been given the same number automatically in the tree. Okay, once we have the numbers, we can simply say add nodes to the illustration or the geometry, and then it automatically does a job of adding the callouts based on where the best fit is. And you can easily go through and edit these. You might want to have just one of the bolts numbered, for example, and they're all, again, because they're all first-class entities, it's easy to go ahead and move them and have full control over how the image is going to look on the output. Okay, so now we have the callouts added, and you notice we have the default set to have the numbers in the circles there, but if you'd rather have rectangles or different colors, you have full control over that. So now Masaru is just going to go in and adjust some colors to make them a little more visible. So we've changed that, and maybe we can adjust the different colors of, such as the background for visibility. Of course, when it's published, this may be published as line art or as a JPEG, which we're going to do in a second. Okay, so we very quickly, in a few minutes, taken our simple assembly, imported it, and laid out an illustration. And now we're ready to publish the illustration as either JPEGs or, in this case, some line art to be used in a technical document. So we have the ability to have full control over our illustration output, such as line widths and what happens to hidden lines and those kind of settings. And when you've got the settings there, when we're just using the standard ones, we're actually now going to preview what the actual illustration will look like. So we're processing the data, and now we have this file that says, yep, if we go ahead and export, that's what it's going to look like. And so we go ahead and export, and here we can choose a format, and we support CGM, SVG, EPS, and DXF formats to output. So we're going to choose SVG and save this as an SVG file. And that was quick. So let's look at the SVG file we saved. And you can see we're opening this in a standard SVG viewing file, which we can get, which is another free tool provided by Lattice, one of our free viewers. But our SVG file is compatible with any SVG viewer, the technology you can find. So here you can see the quality of the output that we can achieve from the data we have. Great. Thanks, Masaru. So now you have an SVG file that's ready for it, can be easily included in any technical document or other area you may want to use it. And if you wanted to further refine it, you could easily take that into another package such as Adobe Illustrator. Okay, if we wanted to export this as a JPEG, and we're seeing a lot of our customers are now actually using JPEGs to replace areas in documentation such as user manuals where they would have maybe used photographs of real objects before, we have the ability to export high-res image files out of XVL Studio as well. And here Masaru is going in and he's setting both the width and height of the document as well as the pixel density. And then when we're ready to export, we can go in, say export image file, and we can choose here from JPEG, PNG, TIFF file, or a BMP file. So Masaru's just chosen JPEG, and he's going to hit save, and it will apply the same name for us. And now we can view this with any standard view that may have. So now we've exported a high resolution image file, and you'll notice we take care of things like putting white borders around the center lines where we need to for visibility. They're all controls that you have, so you can have full control over the visibility of the document. Thanks, Masaru. Okay, maybe save some snapshots and things here at the different stages. Okay, so maybe it's time to save the XVL file. So what we're going to do now is, because we've made a few changes and I noticed we hadn't saved it, we're going to save the XVL file, and it's a chance for us to introduce our free player. And the XVL, what we call the XVL Players, the free player where you can open any XVL file in Internet Explorer browser. And this gives you full access to all of the 3D data. You can actually still see things like the assembly structure. You can view parts individually. You can interrogate parts. You have full access to commands such as the ability to view the snapshots you save. So if you're communicating, you can tell people, hey, open the file and go to snapshot illustration, and they can see exactly what you've done there. So that's the free player. We'll look at that again later when we've done some more work. Okay, so having made a technical illustration, we use only the tools that are available in the XVL Technical Illustration Suite. Now we're going to go up to the next level and use the XVL Technical Collaboration Suite tools to actually create an assembly sequence with some animation of how to put this small assembly together. So first thing we're going to do is use the disassemble command that's part of XVL Studio to just automatically disassemble the parts that let us, so that we can easily create what we call our process tree. Okay, the process tree is can also be called the MBOM or manufacturing bill of materials, where this lets us decide the order of the parts that are going to be in the assembly. So again, you can include all or some of the parts, and you can see here Masaru is just dragging and dropping the parts from the 3D model or from the assembly structure onto the process tree. Now, if this bill of materials exists in an external system, such as an ERP system, we can import, using XML files or CSV files to build the tree automatically. So Masaru is actually doing the job of a process planning here, where he's actually designing the order that these things should be assembled. And again, as we did with the assembly, the disassembly for the illustration, you can include multiple parts in steps, so you can work with sub-assemblies or groups of parts that should be all included at one time in an individual step. So we've built a pretty simple sequence, and now next step would be to go back to our original snapshot, and let's maybe review the assembly order. So now we're and this would be really important if you'd imported this bill of materials from an external source. So we're able to use a check process command to actually go through and look at the individual steps of the assembly sequence. So here Masaru set the visibility to transparent, so that it's very easy to see the part that we're talking about. And here you'd be able to quickly identify if there's any error in the order or any problems you might encounter. So, very useful if you're designing manufacturing assembly or sequences for maintenance operations in the field. And in fact, I think we did put that part in the wrong order. So, excuse me. So now it's very easy to edit that. So Masaru just dragged the part into the right place in the tree, and then we can actually go ahead and recheck that order again. Great. So we can see now we have the sequence of parts in exactly the order we'd like them. Next step is to go ahead and actually create some movement and some animation. To do that, we start from our original viewpoint, and we come ahead and we go into our animation editing area. And this is where we've added some tools that make it very, very easy to create motion. You don't have to be a Disney animator to create this kind of work. And what we're going to go ahead and do there is Masaru just drag the part to the position he wanted and use the insert keyframe command. So, and you can see for each step you can have single steps, you can have multiple steps, you can control all kinds of movement, whether it's radial or linear, and in fact you can also combine them. And if you wanted to input explicit movements such as 100 millimeters or 5 inches or something like that, you can actually input those as coordinate movements as well. And I don't know if you noticed, but for each step Masaru is creating, it automatically creates the path line to show where the animation takes place. And even though we're building up frames for our animation, as you can see on the bottom part of the screen there, we're not having to worry about putting in times or picking keyframe positions. We're just able to let the system do that for us. And it's using the process order that we've already chosen and wanted to work with. Okay, so now Masaru is completed, and we can actually go ahead and review the animation that we've just built. Great. So before we publish this, we'd like to maybe add some different things into this to help with the visibility and make sure that it's communicated correctly with the people who would view it. So we can very easily add cameras or different cameras to each step. And to do that, we simply set the 3D viewpoint using the standard view and rotate commands to the position we want. So pan, zoom, and rotate the view to the right position and click the add camera icon. And it will add the camera to the position that we want. So the viewpoint will automatically change as we want it to. So in this case, we'll rotate it to the different axes. Great. So now if we preview the animation now, you'll see that the camera position will automatically change to the different viewpoints that Masaru selected. So now you can be sure when you send this to the manufacturing environment or service depot or maybe a supplier that's going to assemble the parts, you can be sure that they're seeing the right level of detail. So the other thing that's common in this kind of process environment is to be able to add some kind of text or flashing part warning into the sequence. So we're going to do that now. So here we're going to show you a couple of different options that we have. We're going to add in a text message, and in this case, when the animation reaches this point, it's going to stop. The message will flash, and the user will have to click on the text message to acknowledge they've read it to continue. Or we can add in the ability to make the part flash. So a lot of our users like to have the person click on the part to start the next step of the animation. So that's we can set that up too. So and you can set that up individually and combine the different tools and during your animation. So we've done a couple of different things in here. So now if we preview the animation, let's save the file maybe and preview it in the player. So we're saving our XVL file. We're going to open it in the free player. So now that you can play the animation back in the standard free player. So we go to the animation toolbar. We can check settings. You can make it loop. You can make it do a single part at a time. You can show the paths or not show the paths. And so we've got it set to play the whole animation, show the paths, but it's going to stop at the warnings here. So now you have to click in the text box to continue to acknowledge you've read it. And now in this case, this is showing us the next part. You click on the part, and then the animation continues. Great. So thanks. So hey, before we continue, I think we've created enough data here. Let's look at the file size. One thing we didn't mention after conversion. So we're going to go back out here, and so with the XVL file we created from that 10.5 megabyte CAD file, even with all of the illustration and animation in, is only 205 kilobytes or 208 kilobytes on the disk. So you can see it's considerably smaller and much more easily shareable than that original 10.5 megabytes of CAD. That's, like I said, that's with the animation and the illustration files and the multiple bills of materials that we have included. Okay, so other things that once you've got an animation like this for some kind of assembly documentation, before publishing you may want to add some other information in there. So as we were building the animation, it automatically built this process list data for us. And for each of these steps, you can add other non-graphic information, such as in this case, we're putting in how many minutes we'd like the step to take. You can add comments in there simply by double-clicking and typing in whatever comments you want. So if there's other information that should go into a document that's going to include this animation, then you can type it here. And as with the whole assembly tree or the manufacturing BOM itself, you can import information from a database. So if you have in your ERP system, for example, a set of information that goes with typical manufacturing steps, you can easily import that information into the file, and we're going to do that right now. So that's a way for us to populate all of the different steps here with information that comes out of a database. So once we have that, the non-graphic information tied to the 3D data, we want to go ahead and publish this for people to use. Now, of course, it would be great if everybody had a PC at the desk and the machine or their assembly workstation or out in the field and was able to play the animation. But we know a lot of people actually need to have paper output as well. So once you've got this 3D animation, we can publish both to 3D environments and to printable documents. So in this case, we're going to use an Excel spreadsheet format. And Masari used the output report option that comes in XVL Studio, which is part of the collaboration suite. And that created for us an Excel spreadsheet, which we've opened, which includes all of the information that was in that non-graphic data as well as JPEGs of each step of the process. So you see you have a start and end position for each step. Excuse me. So we can go ahead now, and that's in a standard Excel document, which can be easily converted to other formats such as PDF or used with other Office formats. If we want to publish the 3D data so that we're sharing not only the animation but the instruction information as well, there are add-ons for the collaboration suite that let you publish to either Microsoft Excel or into HTML environments. And in this case, we have a Excel spreadsheet created with our add-on where we have the player embedded. Excuse me. And cross-linked to the 2D information, text information in the spreadsheet cells. So you can see those same warnings and interactions that were in the player can be used in a Microsoft Excel environment as well. Okay, great. Thanks, Nasaru. And as well as Excel, we can publish to HTML. And in this case, we're going to open a HTML example of the same part, which is, again, using Internet Explorer here. We have the player, we have a parts list, and we have the process list that were created from that file. And again, the same warnings are there, and the same parameters that you see in the player. It's just the standard XVL player. Okay, great. Now, of course, in real life, once you've published something like this, that's when you hear about the design change from the design team. So one of the things we've built into the collaboration and illustration suite is the ability to handle design updates. So in this case, we're going to show you what happens when you get revision 2 of the CAD file. So here we go. This is the same part, but now revision 2, and you'll see we're opening a brand new CAD file exactly as we did at the start. And in this case, you'll see that we have a different flange that's much bigger and a different color. Okay, so as we've already been in and we've made, we created the illustration previously, we created the animation previously. How we handle that is inside XVL Studio we have a command called auto update, or in this case we're using auto detect and update. So here we tell it, here's our original XVL file. And that original XVL file that we saved earlier contains the animation and the illustration information, as you can see here. And you can see it, we can go ahead and automatically have the system show us what's changed and what's common. So you see on the assembly tree on the left, you'll see the original in the black and the new in the blue. And you can see down at the cooling fan level, there's A and B options, which is showing us what's changed. And over on in our animation tree, you can see the same options are shown as showing us there's an A and a B. We can verify the change. We tell it the new one. We say, OK, go ahead and update. And now you'll see the animation is automatically applied and updated, so you don't have to recreate it. And we can handle design changes pretty easily. Okay, so then again, of course, if you have the published documents, those documents will be updated to include the new parts. So we very quickly, in about 30 minutes, just a little over there, started with a CAD file, created a technical illustration, published it out, gone in, designed an assembly sequence, created some animation, published that to both print and 3D documents, reviewed it, and handled a design change. In addition, we have the ability to do other things inside XVL Studio, such as some more standard engineering type functions, such as cross-sections. And here you can see Mr. is showing the cross-section capability. Maybe we can save a section. Yeah. And we'll save a snapshot. Okay, we can do standard measurement and annotation type functions. So if we wanted to add some measurements in here, we have standard measurement options such as, radial and between edges, between points, angular surfaces, the ability to measure draft angles. Sorry, maybe you can just add a couple of dimensions. Yeah, great. And we can actually add dimensions in inches or millimeters. It doesn't, you can choose. So if the base model is millimeters, you can add inch dimensions and vice versa. So we can do different types of dimensioning. Add another snapshot. And then the last function maybe we should show, because of time, is the ability to do the review and markup type of functions maybe. So we have the ability to add view-dependent markups or annotations into XVL models using what we call our annotation views. And this lets us add standard red line and markup types of tools, where you can add notes, you can highlight parts, you can mark up directly on the 3D surfaces, you can do all different kinds of things. In this case, we're just adding a standard red line type of function. And then you say it's view dependent, so you can choose how best to communicate what you need to communicate to whoever you need to communicate it with using the tools you want to use. And, okay, so when we've got those couple of annotation views, again, if you wanted to send this to a supplier or back to the engineering team or a manager or something, you can then set up snapshots to help guide the person to whatever they want to see. Or if they have Studio, of course, they could just open up the annotation views, but let's save the model. And now if we go back out to see that model in the player, we could step through, and all of those mock-ups and notes we just saved, you could, easily send to someone and they could view for free. So even the cross-section, for example, this, as I said, snapshot, it's not just an image, it saves the state of the model. So it's very easy to tell people where you need them to look. You can force people to see the right views. And even the markups can be saved as snapshots. Great. I think that's all we were going to cover in our time. In about 35, 40 minutes there. We've been through quite a lot. Vince, back to you.
Yep. Okay, cool. We just got a couple questions we could get to here. The first one, a couple people were wondering, can you import Rhino files?
Rhino files not directly. We have to go through an intermediate format like IGES or STEP or something for that.
Okay.
We've had a couple of requests for that, and I've spoken to Bob McNeil up at Rhino about that, and we haven't quite got off the starting blocks yet. But if there's enough requests out there, I'm sure we could do something.
Okay, cool. Gary was wondering, what if a part needs to move normal to a plane that's not along the X, Y, or Z axis?
Yeah, good question. If you wanted to move a part that's normal to a plane that's not along the X, Y, Z axis, you can do that in the move command. You have the ability to go in and maybe you can pop up the move dialog box. Go back to Studio, yeah. Pop up the move dialog box, and we can show some of the other options. So we just picked the easy ones because we were showing off the software here. But yeah, once you pick on a part, you have the ability to actually go in and choose set up the coordinate axis. So you see, you have a lot of options here to choose. Where do you go? Normal to a plane, normal to a surface. You can set up 3 points to make a plane. You can choose, cylinders or circles. So you have a lot of options there to set up arbitrary movement that's not standard with the current XYZ. So it's pretty easy to do.
All right, good.
I hope that answers the question.
Yeah, I think that was great. Gary has another question. Can it detect clearance issues where a bolt cannot be installed due to an adjacent part?
Yeah. So the question, I'm repeating the question for Masaru's benefit because I've got the headset on.
Oh, okay, yeah.
Was about detecting clearance issues. So if the part can not be installed due to an adjacent part. Maybe you should turn on the dynamic clearance, and we can show what happens. So yeah, so we have within the collaboration suite, you can do what we call dynamic checking here. You can also do static as well, of course, but dynamic's more fun. So in this case, if we do a move now, let's move it away from the part. So as you move a part, and then you hit there. So I hope you can see that well. It's now said there's a collision. It's highlighted the problem for us, and you can choose the behavior, whether it stops, whether it continues, or however you deal with that. So we should have turned that on. So when you're doing moves, that you can move the part and see exactly how that whether it collides or not.
Okay, great. Here's another one. Can you work with CATIA files or NX files? CATIA?
Yes. Yes. Yeah, so we can work with CATIA v5. We're up to, I believe, R20 is the latest version, and NX version 7.5, and version 8 will be out soon, I believe.
Oh, wow. Okay, good.
So maybe you can do the file open, show the file open. We just dragged and dropped the file because we knew it was SolidWorks format, but if we go to the file open, then we can show all the formats we support. So you can see a list here of the different formats there. So we have CATIA 4.5, IGES, Inventor, Parasolid, JT files, PRC, which was the Adobe 3D format, Pro Engineer, Solid Edge files, SolidWorks, Step, NX, 3D Studio, the XF files, and some standard formats like STL and U3D.
Okay, wow, that is a lot.
We probably should have showed that. They're all included with the collaboration and illustration suite.
Oh, okay, good. Okay, so I don't know. Last call for any questions. If anyone out there had a quick one they wanted to get in. Going once, going twice. Okay, so yeah, I think that'll do it for the Q&A. I'm going to switch the screen back over to me, and then we'll wrap things up here.
Vince, maybe we should mention that there's if people want to try this software out, there is a trial version for the suites available. And I'm not sure if they get that through our website or through the Novedge website. I can't remember, but
yeah, okay, yeah.
But there's a 15-day trial version available.
Okay.
The suites full functionality.
Yeah, and I'll send a follow-up email to everyone who attended, and I'll have the link to the trial version in case anyone is interested in that. So that'll be coming within the next 24 hours or so.
Great.
Great. Good that you reminded me of that. Okay, so here I'll just switch the screen back to me, and then yeah. Okay, so great. I want to thank Bill and Saru, both of you guys. It was truly fascinating, exciting presentation. I'm sure everyone out there enjoyed as much as I did. Again, I want to thank everyone who attended this presentation of Novedge's Best of the Best webinar series. In case you're unfamiliar with us here at Novedge, we're the leading online design software superstore. Not only do we have the best prices around, but our staff is extremely awesome. You can call or chat with us at any time. We'd love to hear from you guys. Any feedback on this webinar, any questions about pricing, we're always open to it. Another bit of information I'd like to draw your attention to is WikiCAD. Here at Novedge, we love to go above and beyond for design professionals such as yourselves. We created these online communities to essentially foster the collaboration between CAD users such as yourselves. WikiCAD, if you're not already a member, is free. It's easy to sign up. When you do, you'll gain instant access to the latest news, trends, tutorials, videos, events, CAD-related jobs. It's basically all things CAD on one online community. This webinar will be made available on there for free, as well as on our Novedge website. But complete details with that will come with the follow-up email I'll send to you guys within the next 24 hours. So yeah, I don't know. Bill, was there anything else you wanted to add?
No, I think that sounds great. I'm
Yeah.
going to check out the WikiCAD stuff too. I haven't done that yet. So.
Yeah, please do. Yeah.
I should do that. Yeah.
Yeah. Okay. So yeah. Again, thank everyone who attended, and I'd love to hear from you. My email is vince@novedge.com. The other email you see on our screen is bob@novedge.com. He is our Lattice sales rep, so he will be the best source to talk to about any pricing issues or any questions you had with actually purchasing it. So yeah, again, thank you to everyone who attended.
Great.
Thank you, Bill, and thank you, Masaru.
Great. Thanks a lot. Thanks, Masaru. Thanks, Vince. Talk to you soon.
Take care.